Welcome dear students to video number 9 for standard 9 geometry chapter number 5 quadrilaterals. We are discussing problem set 5. Question number 1. Choose the correct alternative. Answer. Choose the correct alternative answer and fill in the blanks. First one. If all pairs of adjacent sides of a quadrilateral are congruent, then the correct answer is rhombus. Second one. If the diagonal of a square is 12 root 2 centimeters, then the perimeter of a square is, this my dear students you need to solve in your textbook, in your notebook. After solving you will find that the answer is 48 centimeters. Question number 3. If opposite angles of a rhombus are 2x degrees and 3x minus 40 degrees, then the value of x is, again this sum also needs to be solved. You will be using one of the properties of rhombus and you will come to know that the answer is 40 degrees. Question number 2. The adjacent sides of a rectangle are 7 centimeters and 24 centimeters. Find the length of its diagonal. Now, this figure shows us a rectangle ABCD, adjacent sides. So let's take AB as 7 and BC as 24. So we have, let quadrilateral ABCD be a given rectangle. AB is 7 centimeters, BC is 24 centimeters. So in this particular triangle ABC, angle ABC, this angle is 90 degrees. This is angle of a rectangle. So we are going to use Pythagoras' theorem in this particular triangle. And by Pythagoras theorem we have AC square, which is the hypotenuse, is equal to AB square plus BC square, which is 7 square plus 24 square. So 49 plus 576. When I add this, I get AC square as 625. So AC would be square root of 625. Taking square root on both sides, I get AC as 25 centimeters. And AC is the diagonal of the rectangle. Therefore, the length of the diagonal is 25 centimeters. Question number 3. If the diagonal of a square is 13 centimeters, then find its side. So, we have figure for reference. Let quadrilateral ABCD be the given square. AC is 13 centimeters. Let the side of the square be x centimeters. We know that all sides are equal. So if this is x, this is also x. In triangle ABC, I have angle ABC as 90 degrees because this is angle of a square. So again I'm going to use Pythagoras theorem in this triangle. And I'm going to say hypotenuse AC square is equal to AB square plus BC square. AC is 13 square. So 13 square is equal to x square plus x square. I add this, I get 2x square is equal to 13 square is 169. So x square is 169 upon 2. By taking square root on both sides, I get x is equal to square root of 169 upon 2. Now square root of 169 is 13. So I get x is equal to 13 upon square root of 2. Now I don't want the square root in the denominator. I want to eliminate the square root. So what do? I multiply both numerator and denominator by root 2. So I get 13 upon root 2 multiplied by root 2 upon root 2. This root 2 multiplied by root 2 gives me 2. So I get 13 multiplied by root 2 upon 2. Now this I can divide and I get 6.5 multiplied by root 2. That is my side of the square. So side of the square is 6.5 root 2 centimeters. Question number 4. The ratio of two adjacent sides of a parallelogram is 3 is to 4 and its perimeter is 112 centimeters. Find the length of each side. So this is a parallelogram. Let ABCD be the given parallelogram. Ratio of adjacent sides. So let AB is to BC is equal to 3 is to 4. Now let the common multiple of the given ratio be x. So I have AB as 3x and BC as 4x. Now we know that opposite sides of a parallelogram are equal. So I have AB is equal to CD is 3x centimeters and AD is equal to BC is 4x centimeters. Now perimeter of quadrilateral ABCD will be sum of all four sides. I have AB plus BC plus CD plus AD and I know the value which is 112. And these also I know how much. So let's substitute 3x plus 4x plus 3x plus 4x is equal to 112. When I add all these, I get 14x is equal to 112. So x would be 112 upon 14. X is equal to 8. Now let's substitute and find the values. 3x would be 3 multiplied by 8 which is 24 and 4x would be 4 multiplied by 8 which is 32. So I have the sides of parallelogram as 24 centimeters, 32 centimeters, 24 centimeters and 32 centimeters. Question number 5. The diagonals PR and QS of a rhombus PQRS are 20 centimeters and 48 centimeters respectively. Find the length of side PQ. Now let the diagonals PR and QS intersect at point O. PR is given to me as 20 centimeters and QS is given to me as 48 centimeters. We know that the diagonals of a rhombus bisect each other at right angles. This is a right angle and they also bisect each other, which means that OP is half of PR. So half of 20 centimeters, OP is 10 centimeters and OQ is half of QS, which is half of 48. So OQ is 24. Now in this angle POQ, this angle POQ is 90 degrees. So in right angle triangle POQ, I'm going to use Pythagoras theorem. PQ square is equal to OP square plus OQ square. So 10 square plus 24 square. 100 plus 576, I get 676. By taking square root on both sides, I get PQ is equal to 26 centimeters. And PQ is side of the rhombus. So length of side of rhombus PQ is 26 centimeters. Question number 6. The diagonals of a rectangle PQRS intersect in point M. If angle QMR is 50 degrees, then find the measure of angle MPS. Now this particular quadrilateral PQRS is a rectangle. This is given information. We know that diagonals of rectangle are equal. Therefore, PR is equal to QS. Now let's multiply both sides by half. So I get half PR is equal to half QS. I'm going to name this statement as statement 1. Now PM is equal to half of PR. PM is half of PR and MS is half of QS. This is statement 2 and this is statement 3. And on what basis have I written these statements? Diagonals of rectangle bisect each other. So if I compare statement 1, statement 2 and statement 3, from statement 1 to 2 and 3 I can say that PM is equal to MS. So I have PM is equal to MS. Now look at this particular triangle. This triangle. I have PM is equal to MS. Now if both these sides are equal, I can say that this angle is equal to this angle. Angle MPS is equal to angle MSP. They are congruent because then if these sides are equal, then this triangle becomes an isosceles triangle. I'm going to name these angles as X. Let angle MPS is equal to angle MSP is equal to X. I'm going to name this as statement number 4. And this angle QMR is given to me as 50 degrees. It is vertically opposite to angle MPS, and we know vertically opposite angles are equal. So if this is 50 degrees, angle MPS is also 50 degrees. This I'm going to name as statement number 5. So in triangle MPS, angle MPS plus angle PMS plus angle MSP is equal to 180 degrees. Sum of measures of all angles of a triangle is 180 degrees. And I know all these angles. See, both these angles are x degrees and this angle is 50 degrees. So 50 plus x is equal to 180 degrees from statements 5 and 4. So x plus x is 2x. 2x is equal to, I take this 50 on the other side, I get 180 minus 50. 2x is equal to 130. X is equal to 130 upon 2. X is 65 degrees. So therefore I get angle MPS. This was x. So MPS is also 65 degrees. Question number 7. In the figure, if segment AB is parallel to PQ and AB is congruent to PQ, segment AC is parallel to PR and AC is congruent to PR, then we have to prove that segment BC is parallel to QR and BC is congruent to QR. So let us start. In quadrilateral ABQP, this quadrilateral ABQP, segment AB is parallel to segment PQ and segment AB is congruent to segment PQ. This is given information. And we know that when a pair of opposite sides is parallel and congruent, then that particular quadrilateral is a parallelogram. So I can say that quadrilateral ABQP is a parallelogram. If this quadrilateral ABQP is a parallelogram, that means the other pair is also parallel and congruent. So segment AP is parallel to segment BQ and segment AP is also congruent to segment BQ. This I'm going to name as statement 1 and 2. Now let's move to other quadrilateral. Quadrilateral ACRP. This quadrilateral ACRP. Segment AC is parallel to segment PR and AC is also congruent to PR. This is given information. Therefore, again, according to property, a quadrilateral is a parallelogram if a pair of opposite sides is parallel and congruent. I have quadrilateral ACRP as a parallelogram. And I can say the other pair is also parallel and congruent. So segment AP is parallel to segment CR, and segment AP is also congruent to segment CR. This I am going to name as statement 3 and 4. Now let's move to the third quadrilateral. Quadrilateral BQRC. This quadrilateral BQRC. From 1 and 3, I can say that BQ is parallel to CR. From 1 and 3, I am saying BQ is parallel to CR. And from statement 2 and statement 4, I can say BQ is congruent to CR. So again, if a pair is of opposite sides is parallel and congruent, then I can say that this quadrilateral is a parallelogram. So quadrilateral BQRC is a parallelogram. If it is a parallelogram, then the other remaining pair is also parallel and congruent. So I get in quadrilateral BQRC, BC is parallel to QR and BC is also congruent to QR. Hence proved. Question number 8. In the figure, ABCD is a trapezium. AB is parallel to DC. Point P and Q are midpoints of segment AD and BC respectively. Then prove that PQ is parallel to AB and PQ is equal to half of AB plus DC. In order to do this, we need a small construction, and that is draw AQ and extend it to intersect DC produced at R. So let us start. Line AB is parallel to DC. This is given information, and BC is the transversal. So I have angle ABC congruent to angle RCB. These are alternate angles. That means ABQ, angle ABQ is congruent to angle RCQ. This is my statement 1. So in triangle ABQ and triangle RCQ, my first statement is angle ABQ is congruent to angle RCQ from statement 1. Segment BQ is congruent to segment CQ because Q is the midpoint of BC. And angle BQA is congruent to angle CQR. These are vertically opposite angles. Therefore, I have triangle ABQ congruent to triangle RCQ by ASA test of congruency. And once I have these triangles as congruent, I can say that segment AB is congruent to segment RC. Corresponding sides of congruent triangles, this I am going to name as statement 2. And segment AQ congruent to segment QR, again CSCT, statement number 3. Now in triangle ADR, this big triangle, I have P is the midpoint of AD and Q is the midpoint of AR. This is given information and this is from construction. So I can say that PQ parallel to DR by midpoint theorem. PQ parallel to DR. That means PQ is parallel to DC because D dash C dash R. This is my statement number 4. PQ parallel to DC is statement 4. And I know that PQ is parallel, I know that DC is parallel to AB. This is given information. DC is parallel to AB. So let's have a look at statement number 4. PQ parallel to DC and DC parallel to AB. That means PQ is parallel to AB from 4 and 5. I can write that PQ is parallel to AB. PQ is parallel to AB. So this part is proved. Also, PQ is half of DR. Again, by midpoint theorem, I can say PQ is half of DR. So PQ would be half of DC plus CR, because DR is DC plus CR, D dash C dash R. And I know that CR is equal to AB. I know that CR is equal to AB. Look at statement 2. AB is equal to RC. This is CR. So instead of CR, I can write AB over here. So I get PQ is equal to half of DC plus AB. That is PQ is equal to half of AB plus DC. Hence proved. So this part is also proved and this is also proved. Question number 9. In the figure, quadrilateral ABCD is a trapezium. AB is parallel to DC and points M and N are midpoints of diagonal AC and DB respectively. Then prove that MN is parallel to AB. So in order to do this, there is a small construction. Draw DM and extend it to intersect AB at point T. So now let's start. We have DC parallel to AB given information and line AC is the transversal. So I have angle DCA is congruent to angle BAC, alternate angles. DCA I can also call as DCM, that is angle DCM is congruent to angle TAM. This is my statement number 1. Therefore, in triangle DCM and triangle TAM, I have angle DCM congruent to angle TAM from statement 1. Segment MC congruent to segment MA, because M is the midpoint of AC. And this angle, please rectify this. This is supposed to be angle DMC. So angle DMC is congruent to angle TMA, vertically opposite. These are vertically opposite angles. So I have this triangle, triangle DCM is congruent to triangle TAM by ASA test of congruency. And once the triangles are congruent, I can say that this segment, segment DM, is congruent to segment MT, corresponding sides of congruent triangles. This I am going to name as statement number 2. Now in triangle DTB, this triangle DTB, this triangle, I have N as the midpoint of DB. This is given information. And I have M as the midpoint of DT from statement 2. See over here, I have DM congruent to MT. That means M will be the midpoint of this particular segment. So M is midpoint of this segment and N is midpoint of this segment. So by midpoint theorem, MN is parallel to TB and TB means AB, because we have A dash T dash B. So AMN is parallel to AB. Hence proved. My dear students, with this we finish chapter number 5. Please write all these sums from all the exercises what we have discussed in previous videos and problem set 5 neatly into your geometry notebook. Thank you. Have a nice day.